Record. Okay. So we figure out our ABC from the formula, from the original equation. We plug it into our quadratic formula, and now we're doing a little bit of solving. 2 times 4 gives me 8 on bottom. I'm gonna give you all a few seconds while I delete this. I bet you could figure the rest of this out now. Probably makes it a little bit easier if you add that 48, because I think that's going to end up giving you so order of operations. We kind of look at that radical, like we have to do everything underneath the radical before we bring it out. So what am I getting here?
I didn't quite get that far.
48.
7 divided by 8.
Yeah, but 48 and 1 is going to give me what?
49.
Yeah, 49.
49, and then you
So if
divide
we do
that by
that,
like 7/8.
49 is 9 is 7.
Root 49 is 7.
Hmm.
And we're dividing that by 8.
And we can't factor that anymore. Simplify, sorry.
Yes, we can.
What 2 things does that give you? That gives you 2 different things, right? Write those things out. So one of them is
It'll equal 1.
yeah, one of them is 1 plus 7, right?
Mm-hmm.
Mm-hmm.
The other one is
1 minus 7. So that'll be a negative, or sorry, what?
Yeah, plus.
yep.
Negative 6/8.
Yeah, so we got a little simplifying to do. But if I have something like 1 plus or minus 7/8, I can simplify this into what? 1 plus 7/8. That's giving me 8/8 or 1. If I do 1 minus 7, that gives me a negative 6/8. And so I think that's giving me a minus 3/4.
3/4.
Yeah, minus 3/4. Divide top and bottom by 2.
So you have 2 X answers here.
And you're getting 2 answers. Is that what we're expecting? How many solutions are we expecting?
I don't know.
I don't know. What did we start out with? What sort of equation?
Quadratic.
It's
So we're looking
quadratic.
for
That's
a split.
degree 2. So
So
how
we're
many
looking for 2.
solutions? 2 solutions, right? We should be getting 2 solutions for quadratics. Okay. And I didn't say it, but this should be x equals 1, x equals a minus 3/4. I drop my x equals somewhere along the lines.
Teacher, it's the opposite. It's 3/2 and minus 1. Because we have minus 1 plus minus 7. One of them is going to be a minus 1 plus 7/8.
Was there
Which
minus 1 on there?
Yes, we have minus 1.
Did I drop my minus somewhere along the lines?
I don't
It's
know
a
where
possibility.
you put your minus. Because we have plus and
It should be minus. Yep. Sorry.
no problem.
There
Because I'm
should have been a
looking for my
minus on this
solution.
one. Yep.
Yeah. It's going to be 3/2 and minus 1.
It should be 3/4 though, right? Because it's divided
Yes,
by
3
8.
oh, sorry, 3/4. 3/4 minus 1 because of the minus. Yeah.
Yep. Should have led with the negative, and if we lead with that negative, I think it comes into play on this step, right? Minus 1 plus 7/8 is where we start first using that negative one.
Yes.
Yeah, I dropped a negative somewhere along there. So
Maybe you're angry.
I was gonna say, do as I say, not as I do, right? This is a really common mistake, and I see a lot of students make it, and now I think I've made it. So don't do that. Keep track of your negatives. I think we could have also done this. So we get x equals a minus 1 and x equals 3/4. These are both just like rational numbers, and so I think we could have factored this thing. I'm pretty sure. I know we could factor it.
Yes, we can factor them too. Yes.
Yeah, we could absolutely factor this thing and solve, right?
Yep.
And so if we can factor, why do we have quadratic?
N plus 1 and 3. N plus 1 and 4, N plus
Maybe.
minus 3.
Maybe that's a weird question. I probably should ask it slightly differently. But like we could factor with this one, right?
Yeah.
Can we factor everything that we've seen?
What do you
Everything
mean?
that we've seen, have we been able to factor it? Like
Yeah,
two
we can
factors?
factor it in this case.
In this one we can, but like there were
It's
things
not,
that we
it's
called,
not, all- no,
right? There were things that we called prime, right? Before
yeah,
that we couldn't factor. We couldn't factor them and we couldn't solve them. I think maybe we could have solved them with the thing that we threw out, the complete in the square. Maybe we could have solved them with that or something. But I'm trying to get you to think about like, why are we doing this quadratic formula? And how does it fit in with like factoring and the things that we know? Because factoring solves it, but not everything is factorable, right?
yes.
And so we need a method. We need some sort of method that's always going to sort of get us there. And so this is sort of like, I'm trying to think of how to do it. It's like no holds barred sort of thing. We can do any sort of equation we want, but it's super big, right? If we type out this thing every single time x equals a minus b plus or minus the square root. So I'm hoping y'all are writing this out because it's the best way to sort of learn it. B squared minus 4ac all over 2a. Right? Do you really want to type this thing out every single time that you have to solve an equation? If you can factor it, I would probably solve it by factoring. And in general, like when we're not in this section that's specifically about, you know, the quadratic formula, they're probably going to generally tell you solve this equation to the best way that you know how, right? And so being honest, that first one, if I was given it and that those were my instructions, I wouldn't be using quadratic formula for it. Quadratic formula is big and bulky, right? It's the big gun that like gets everything done. It's not necessarily the best tool all the time, but if you
But
don't
in
know
the-
how to factor it, right? If you're just like completely lost on factoring and completely forgot on factoring, this thing will get you there.
But teacher, in the test, for example, you are going to be specify, right? If by factoring we solve the equation by factoring or
Yeah, it might specify, right? If we specify we want it solved by quadratic formula, then we want, you know, obviously the quadratic.
Yeah.
But in general, I think usually on my test and stuff, I say solve it by the best way possible. So if you can factor it, that's better than using quadratic. I wouldn't count it wrong if you use the quadratic formula, but you're not saving yourself time on your test, right? By using this thing, it's definitely going to take some time up on your test if you use this. In factoring, I think y'all are a little bit quicker on now. Hopefully you've had some practice. Like if I gave you that first one, asked you to factor and asked you to do it quadratic, I almost guarantee you most of you would do it quicker factoring. This one, who's next on my list? Josh, did you get this one?
I'm most of the way through it. I can start it.
All right. So what about
So-
that minus b? What does that thing look like?
So I took B, which was -6, and I made it positive because I'm just reversing the sign.
So this was something got asked earlier this morning, but when we do this, this is actually -6. So if there's a negative in the formula, if you wanted to just write +6 right off the bat, that's fine. But somehow we got to account for the fact that there's a negative on the b and there's a negative in the formula. So overall, this thing is going to end up becoming positive. B squared, that's the other thing. What does that look like?
Put it down as -6 squared,
All right, so
and I had to put that inside parentheses to put it in my
Yes.
calculator.
you want to be careful with this thing too, right? Because the negative does get squared. So b squared, this thing should always be positive when we square it, after we square it. minus 4. A times C is what, 2 times 3, I believe.
Yeah.
And we're doing this all over 2A, which is 2 times 2.
Yes.
All right, we have our formula. We're picking out our A, B, C from our formula, from our equation. We're picking out A, B, C and from our equation. We're throwing it into our formula, our quadratic formula. You got to sing Little Bunny Foo Foo to remember this thing, do something, right? If you don't like Little Bunny Foo Foo, there's the Row Your Boat video they put on your notes. I think everyone's got a different song for it. Find one that you like, I guess. We have a little bit of simplifying to do in this one. So if we look at this is x equals minus 6. I believe this is what, positive 6 plus or minus. Now we got some maybe order of operations that we got to do. So we have a minus 6 squared. That's the first thing I see there. Exponents should become first, hopefully.
You'll get 36.
This is going to be 36. And now we have this thing over here. And so what I would probably personally do, there's a few different ways to do this. I would probably count the negative signs. How many negative signs do you see on that right-hand side?
One.
Yeah, there's like one negative. And everything's just getting multiplied, right? So if we do 4 times 2 times 3, what's the number we get?
24.
24. 4 times 2 is 8, times 3 is 24. 2 times 2, ooh, that's a big one. All right, there we go, 4. All right, are we together on this? Hopefully.
Mm-hmm.
X equals 6 plus or minus. We have something in a radical and we have something over 4. So what's going inside this radical over here?
Well,
Um,
36 minus 24.
Yeah, 36 minus 24 should give me,
12.
it's 12, right? Okay, I was making sure I did that. Okay, we got this thing. It's getting cleaned up a little bit. Ooh, man. What was that thing I said? Like this class is going to build on itself. Look at this. This is old material right here, right? We got this root 12. I wanted to clean this up. We're almost there. We're getting close.
Mhm.
How do I clean up a root 12?
The square of 3.
3 times the square root of 3.
Yeah, 2 square root of 3. We have a 4 and a 3. That might look like a 2 square root of 3. Okay. There are a few different ways to simplify this. I would probably separate it and simplify it. I feel like less students will like go awry if we go that direction. If we try to simplify it all as one big thing, a lot of times people kind of mess it up and don't divide everything they're supposed to divide. So what should this look like if I separate it?
6.
6 over 4.
I have a 6 over 4 and I have a
2 radical of 3 over 4.
plus or minus sign in between, and I have something that looks like 2 radical 3 over 4.
I'm gonna divide the whole thing by 2 and to clean the equation.
Yeah, so 6 over 4. We can divide that by 2, which is what? 6 divided by 2 is 3.
Over
4
2.
divided by 2 is 2. So 6/4 is the same thing as I believe 3/2.
Mhm.
I'm gonna do a little work here. So divided by 2, this gives me 3. Divided by 2, this gives me 2. What about this thing? 2 square roots of 3 over 4.
Would
Same
they give
thing.
you one-
Like one of them, it's going to be 3 plus square of root 2. The other one, it's 3 minus square 3 of 3.
We
Of
can
4,
divide,
yeah,
yeah, we can divide that 2 and that 4, right?
yeah,
Okay. And so this is gonna give me root 3
over 2.
over 2. Is there anything else I can do to that thing? Can I simplify that any further?
No,
I think that's gonna be my solution there. If you wrote it as something over the same thing, I think that's okay here as well. Right? If we wrote it over the same 2. Ms. Wise, do you have a preference for how they solve these? Whether it looks like separate, whether they separate the 2. I prefer that they separate them personally, but I would count either one probably correct.
I would count either correct if they reduce correctly. When they don't separate it, they often reduce incorrectly. So that's why I usually recommend they separate them so that they reduce them properly.
Yeah, that's basically what I was telling them.
I didn't separate them. I just wrote them as 3 plus square of 3 over 2. The other one is 3 minus square of 3 over 2. It's like the same thing if we separate them or now, right?
Yeah, I think the thing is, like, usually when we don't separate them, people will try to do something silly, like just reducing those 2, right? And they won't
Yeah.
reduce the 6 as well. They'll reduce like the 2 and the 4, but they won't reduce the 6. Or they'll reduce the 6 and the 4, and they'll like miss the 2.
Or
Yeah.
let's say it's like a 12 on the bottom, then they'll reduce the 6 and the 12, right? Like they do all kinds of weird things. And traditionally we do separate it, I guess, right? I feel like it's separated, but either is
Yes,
fine as long as it's done correctly.
especially when you start getting eyes in there, you want to separate them probably because that's going into like the standard form of the imaginary numbers, right? We really like to have things in standard form.
Okay, no problem.
I mean, that's like the last step of the problem there, right? If you're getting all the rest of it, that's a pretty good sign. Okay, any questions before we go back to groups? So what were the next 2 we had? 125 and 129. I think this is what we want to work on next.
I have a question. I know this is kind of strange, but if it's 2 negatives, like up under the radical, that means it's gonna be a positive. If it's 1, that means it's gonna be a negative.
Are you talking about the 3 numbers that we're multiplying there?
Yeah, yes, because like as we're doing the problems now, I see what I'm doing wrong, and it's like I'm getting my sign mixed up. So I just trying to make sure. So if it's 2 negatives, you know what I'm saying?
So if it's 1, yeah, so if A and C are both positive, right, this thing is going to end up being negative in the middle. If one of them's negative, I think it ends up flipping the sign. So counting your negatives and counting whether it's an even or odd number of negatives might help you end up getting what the overall sign is. Because these things are just multiplied, right? We're just multiplying 3 numbers.
Right.
That's giving you the number. What gives you the sign is how many are negative or positive. So if we have 1 negative, we have a negative in the equation. So that's 2 negatives total. Is going to flip it to positive. But if we start doing what? If A and C are both negative, then I think this is going to end up being 3 negatives. Overall, that sign should be minus.
Okay.
So counting negatives, and yeah, whether it's an even or odd, they call that parity, Parity. The big fancy word to describe whether something's odd or even, basically. Whether you can put it in pairs is the way I think about it.
Okay, thank you.
So 125 and 129, are there any questions before we go and start working on those? Okay, I'll open rooms back up. Do you usually test them over the discriminant?
I mean, in a pre-calc class or an algebra 2 class, they would mention it.
I mean,
There's
we mention it and we go through it in the homework and stuff, but like I can't ever say I've ever written a test where I would just like determine a discriminant and how many solutions it has. I mean, I could be wrong. Maybe it's on there. But usually you use that as a tool, not so much just. I usually don't give them.
You're still recording, just so you know.
Okay. So what is my A value? I don't see an A value here.
I just put 1.
1? Is that right? That's it. 1x squared. That's my A. This is my B right here. And this is my C, hopefully. And so minus B should look like what? Minus.
Negative 8
Uh-huh.
plus or minus the square root of 8 squared minus 4 times 1 times negative 4. And then over 2 times 1.
Okay. Is that what y'all are getting? Did you get the same thing, hopefully?
Yeah.
Okay.
Yep.
Okay. And this is a minus 8 plus or minus. So we got a little bit of cleaning up to do inside this radical. I think the first thing is exponents, I believe.
So I
So
got
we-
64. 8 times 8 is 64.
Mhm.
And then I just did plus 16.
What was the sign?
Plus.
Plus 16. So 4 times 1 times 4 is going to give me 16. That's it.
And then over 2.
Yep. That's the next step. And so after that,
And then I got negative 8 plus or minus. And the square root of 80 over 2.
okay, and then this thing, right? We can clean, hopefully this thing. This is going back up to the stuff that we're doing right before the test with the radicals.
Mhm.
How do we clean up root 80?
So I got the 2 radical of 5 divided by 2.
I think it's what?
It's 4 square 5 square.
4 and 20. I think this is going to give me 4 and 5. So I think we can pull out 16 from there, or 4.
Yeah. It's going to be 16 times 5, and 16 is 4 square root. And it's, yeah.
So I think 80 is going to end up becoming 4 square roots of 5.
Yeah.
You can do 16 times 5 is one way you can do it. Or you can do 2 times 2 times 2 times 2 times 5, I believe. Each one of these is a 2.
It's just 4 squared times 5, and you put your 4 square out. It's going to be 4.
So this is, I know this is a review, but it's still stuff you just learned, right? Probably like not that long ago. So this is still pretty fresh for a lot of people, I feel like. So being able to simplify these radicals, it's going to pop up quite a few times when we do this. Are there any questions about how to simplify this radical? Do I need to break it down further? Okay. And so we simplify the radical into 4 root 5. Oh, that was a 2 from that previous one, huh? So if I do a try to cram it in here, minus 8 plus or minus 4 root 5 over 2. And so who was I talking to? Kathleen?
So I simplified that, divided it by 2, and I got negative 4 plus or minus 2 with the radical of 5.
Okay, so we're dividing, yeah, so you got to make sure you're going to divide this by 2, you're going to divide this by 2, and you're going to divide that, right? So if you want to separate it, we could separate it. If not, I think you did it correctly. It sounded
Okay.
like it. -8/2 plus or minus basically 4√5/2.
Mhm.
It's a plus or minus. And so I think the first thing you did was a -4 plus or minus 4 divided by 2 is 2, and then you have a √5. And I believe that's what you told me.
Yes, is that right?
That's it.
Okay.
So this thing right in here. If you wanted to write it as two separate things, like -4 plus 2√5, -4 minus 2√5, that's fine as well. So how many solutions is that?
2.
Does that give you your two solutions? Yep. So the plus or minus, right? Like, and that's also why I said if you want to write it separately, you can, right? That plus or minus gives you two different things. Okay. Questions about this one? All right, that was a 125. The next one is 129. 129 says 2x squared plus 3x. Plus 3 equals 0. Did y'all get through this? Do y'all want more time on this one?
I didn't.
You did it. Does anybody want more time? Or should we walk through this one? If you want more time, I'll give y'all more time. Don't be afraid. This is your practice. Are we good? All right, so let's do this one then. So if you haven't written this, I hope you wrote it. This should be the first thing you hopefully write on your paper. And who's the next? Sage, did you get this one?
I got like halfway through it, so I can try and help you.
All right, sure, help me out. X equals a minus b is going to look like what?
So I got -3 plus or minus, and then under the square root 3 squared minus 4 times 2 and times 3 over 2 times 2.
Yeah, filling out my a, b, and c into this formula. 2 times 2 on the bottom is 2 times a. Did we all get this far? This is like a good half the problem, I feel like, almost, right?
Yeah, that's about as far as I got.
The rest is like, can we look at the original equation? Can we fill that into our formula? After we fill that into our formula, then we got a little bit of maybe like some PEMDAS to do to clean this thing up. But this is heading us pretty good in the right direction, right? So that -3 plus or minus root. And if I'm looking at things underneath that radical and I want to clean them up, the first thing I'm looking at is that guy right there, right? So what is that exponent going to be?
9.
9. I mean, yes, that wasn't the German response, if that's what you're thinking. Yes. And then we have what? 4 times 2 times 3.
I got -24.
All right, so yeah, 4 times 2 times 3 is going to give me 24, and I have one negative in there that came from the formula itself. Overall, that thing is going to be negative. 2 times 2 is going to be 4. Okay, So I'm gonna have to maybe erase this one really slowly. All right, what's the next step here? I have some more stuff to do in this radical. When I do that thing in the radical,
It would be negative 15, but you would have to do -1, the square root of -1 times square root of -15, right?
yeah, you could do that. And so what is that? How's that gonna come out?
You would get I square root of 15
Yep.
over 4.
And I'm cramming it in on the corner over here on my tablet. -3 plus or minus I root 15 over 4.
I have a question.
Mm-hmm.
So the I goes on the outside.
Yes, make sure you put that I on the outside of the radical. If it's inside the radical, it is something different. Right? Square root of I is not equal to I. Those are different things. So whether you put it on the outside or inside of the radical, it makes a difference. And so if you did this, you're pretty good. I would probably give you credit. What am I probably going to do?
You want to separate them?
Yeah, I'm going to separate it. And I said I'll give you full credit because there's nothing else to simplify there. We're not going to divide 3 and 4, right? There's no common factors. There's no common factors between that I and the 4 or the 15 and the 4. That 15 is 3 and 5. There's nothing we're going to simplify out of that radical. So if you try to simplify out of that radical, it's just a 3 and a 5 in there, and neither one's going to come out.
I mean, it's not like simplified, just to separate them as A minus B minus plus I of B. What do you want to say?
And so this, the reason why we kind of like this is like our standard form A plus BI. We have our real part first, and then we have our imaginary part first. So that's why we like tend to go in that direction of separating those things. Because when we're talking about real numbers, not real numbers. When we're talking about imaginary numbers, right? Complex imaginary numbers, we like to have the real part first and then the imaginary part second. Do y'all see what I'm talking about? Hopefully. Because there's one that looks like this. And if we really wanted to go full on out, we can maybe say this is this with an I. But that gives me my real part and my imaginary part kind of separately. If you put this, or you put this, either way, or you wrote them out separately, I feel like you put any one of these 3 things on your paper, we're probably going to count it right. I would count it right. Questions about this one? Which one was this? We did that one. That one. We didn't do the next one, right? This is 129, right? So what it did?
Yes.
Yeah. And the next 2 that we need to do are 131 and 141. And then the last problem is just about discriminants. So we will talk about that. But if you can do the quadratic formula, you can do the discriminant, I almost guarantee you. The discriminant is just a big fancy word for saying, hey, that thing that's under the square root, right? What is it? And so just knowing what's under the square root, we can determine what sort of solutions we're getting from this thing. Questions before we finish off those last 2, or then do that third one? All right, so the last 2 were what? 131, 141. Is that the numbers y'all got? 131. and 141. All right, so if there's no questions, we will go to groups one last time. And pause the recording.
Yes, the first two parts, yes. So I got 6 plus minus the square root of negative 6 squared minus 4 times 8. Sorry, negative 4 times 8 times, and then 2 times 2 over 2 times 8. And that'll equal 32 times negative 32 times 2 is negative 64. It'll be 36. It'll be 36 minus negative 64. So that'll make it plus 64.
Okay, so I wanted to
So 30
just to say like we have a 6 out in front, and the formula it's a minus b, but our b was 6. So if there's someone's confused about that, there was basically a double negative on this thing, right? And you said this is just a positive 6 then.
Yes.
So we get 1 negative from the b, we get 1 from the formula. And now I'm looking at this thing. That's my original equation. This is my quadratic formula. I've plugged my equation into the quadratic formula. And so I'm looking at this thing, 6 is still there, plus or minus. I want to do some cleaning up in this root. And so you said minus 6 squared should give me what?
36. And then it'll be negative 32 times 2, and that it's negative 64.
That's it. And then on the bottom, it should be
16.
16. Yep.
And then after that, you do 36 minus 64. What is that? 28 and 28 over 16.
Okay.
Okay, 28 over 16.
So the next thing that we're doing is that 36 minus the 64. That's going to give me 6 plus or minus. Root, you said 28.
Negative 28 over 16.
Should be minus 28 over 16. Yeah, that's it.
This is where I don't do after I get the negative in the square root.
So the negative in the square root should come out as what?
An I.
Yeah, so there should be an I here. This thing, how can we break apart 28?
Square root of
Probably do 4 and 7.
I got it. Yeah.
And so what's going to come out? And what's going to stay in? Root 4 is what?
2.
2. So the 2 should come out. Root 7 is just
Staying in there. So.
in there. Yep. So knowing how to break apart these radicals, that's going to come up. If y'all didn't learn that already, it's coming up again, right? Gotta get those. I'm sorry, what was that?
You would do 6 by 16, or what would you do from here? I think it's simplified.
Yeah, so you're pretty much, you're almost there, right? 6 over 16, and we have like what, plus or minus, and we have a 2i root 7, and that
You can get rid of
also
2.
over what, 16. That first one you said divide by what?
You can simplify the I, right? And the 16, the 2i and the 16.
Yeah, I was doing the 6 and the 16 first. So 6 and 16, we can divide those both, I believe, by 2, right? Will give us 3/8.
Mm-hmm. And be plus or minus I square root of 7 over 8.
Yep.
I did it.
Questions about this one? Are we getting these?
I understand it.
Okay. And so the little last square root problem we have for the day is what, 141. So I want to take a minute. I'm going to write out the problem right quick. So it was 16c squared. And we had a class. And if you were doing what you're supposed to in the class, hopefully that'll help you get there. But I want you to do this, and I want to write out this formula. So we tried it at the beginning of class. Now I want you to try it at the end of class. Give it an honest attempt. I'm going to give you all like 1 or 2 minutes to do this thing. Write out the quadratic formula. Try it. Try it without looking. That's what I want to. That's what I want you to do. What does that thing look like? Oh man, I worked at a tutor as a tutor at the Eastview campus for a while. Someone decided to tag this in the stairwell, but they didn't write it correctly. They missed the sign on it, and it really annoyed the heck out of me. It got corrected eventually. I didn't. People can't be looking at the wrong thing. At least if you're gonna tag it, tag the right thing. I don't know who fixed it, but they did. They did. That was like some. I don't want to say. Probably shouldn't say too much. It's probably the best thing. All right, where we're at. That's enough time, hopefully. So what does this look like? I hope you did a minus b plus or minus square root of b squared minus 4ac. All over 2a. And if you did that, that's right. Leslie, did you get this one?
Yes, I did. I just got stuck at the end, but I'll do it.
All right, help me out. Just get at least that first step there, right? Minus b looks like what?
It's negative 24. And then it's plus or minus square root of 24 squared minus 4 times 16 times 9 over 2 times 9.
Yep. 2 times a, is that what we're doing on bottom?
Yes.
What is my a?
Oh, wait, never mind. Oh, that's where I messed up. So it's 16.
Yep. So minus b is, yeah, minus 24, and then we're going to do 24 squared. I really should extend this radical. 24 squared minus 4 times 16 times 9. And like, I'm looking at this and I'm already got my calculator to double check. These are not nice numbers, right? The other ones, I feel like you could have probably done them in your head for the most part, maybe. You can tell me what 24 squared off the top of your head is. I'd be pretty amazed.
And then
So if I'm starting this, I think I have a minus 24 plus or minus. Yeah, sometimes they tend to give you nicer numbers. If you write down the wrong thing, it might make life a little harder. 24 squared, I think is the first thing I see there. So if I do 24 and I square it, I'm going to get what?
it's 576.
And then we're looking over here.
It would be
Overall, is this going to be plus or minus when I get done multiplying these things?
So minus.
Heard someone say it. It's going to be plus or minus.
Minus.
Yeah, it should be minus. And how do we know that? Because there's one minus here, and then the 16 and that 9 are both positive. So overall, I think I have one negative happening there.
So then
If I do 4 times 16 times 9, I think that's the next thing I want to do. What does that give me?
576.
That gives me that same number I got there, 576. 2 times 16 is,
32.
ooh, excuse me, yep, 32. I am recording, right? Yeah, okay. And
It would be negative 24 plus or minus square root of 0
ooh, yeah.
over 32.
What is the square root of 0?
100.
No.
Of course, no. It's 0.
Square root of 0 is 0, is that right? Can we
Yes.
do that?
Course. Yeah.
Is 0, 0 a point on a square root graph? Yeah, that's it. 0 times 0 gives us 0. Square root of 0 is 0. I think that's the one thing that like really trips people up. It's like square root of 0, what is that? It is 0. Square root of 1 is also 1. That's another weird one.
Okay.
Okay.
Minus 24 over 32.
So what do we have here? So I know I have a lot of stuff written up here. Let me make a little bit of room, maybe. We end up with minus 24 plus 0 and minus 24 minus 0 over
So you
32.
get number.
So you probably want to, if you didn't do it, I don't know if you want to separate it, you can. Whether I do minus 24 plus 0 or I do minus 24 minus 0, what am I going to end up getting?
Minus 24 over 2.
Yeah, those are giving me the same thing, right?
Yeah.
And I could probably clean this up. 24 and 32, I believe, are both divisible by 4?
By 8.
8?
Yes,
8.
by 8. It's
So if we
going to be a
divide these
minus
both
3
by 8,
or
I believe we're getting what, minus 3/4?
yes, minus 3 over 4.
Okay, I got this. Now I'm probably going to ask a confusing question. This is my x equals minus 3/4.
Mhm.
That's my solution for that original equation. If you want, and we didn't do it, but you could go plug these back in, right? And you could check that original equation to make sure it's true. How many solutions was I expecting?
1.
1.
What? What kind of equation did they give me?
Wait,
We have
because
just
So I start with the quadratic. I'm expecting,
two,
two,
but in the
but-
end, we
but
find
it's
one.
1 because it's a 0.
it's 1 because this thing was 0, and we get 2 different solutions, right? But the thing is, they're the same thing. They're the same solution. So we get one solution, but it's repeated twice. So we're still getting our 2 solutions that we're expecting, but it's the same thing.
Yes.
So if we get a 0 there, we get that one repeated solution. And I think that's leading into the next sort of problem, right? They're like, what about our discriminant? Where are we at? Okay, we got time. And so they give us a few things like r squared plus 12r
Minus
plus
no,
36 equals
plus
0.
36. 0.
And they don't want us to do the whole thing. They just want us to do the thing that's underneath the square root. So
This
we're
is the-
finding this out. But there are basically, what, 3 different things they want to talk about. And what are they going to mean? So let's go over that. B squared minus 4ac. If it's negative, what does that mean?
Zero.
If it's 0 or if it's positive, right?
Yeah.
So if it's 0, we just did this. What sort of solution does that give us? Like x equals 3/4? What sort of thing was that? Is that real or is that imaginary?
It's a real number.
The real. And it repeated, right? I can't even spell repeat now.
Mhm.
So the 0 is the real repeated solution. If I get
We
a
need to write-
negative,
Excuse me, teacher. We need to say that is the real repeated solution. You want us to say it, or just the solution is the real number?
so you would say real, and you would probably want to know that you're only going to get one solution, that it's going to be repeated.
Okay.
If you told me one real solution, that would be fine. If you told me one real, or if you just said it's a real that's repeated, something along those lines. If it's a negative number in the square root, we had things that they had a negative number in the square root. What did we do with that negative in the square root? It came out as a. It comes out as an I or an imaginary number. So this is two imaginary.
Mhm.
So we get 2 imaginary there. We get 1 repeated. If it's 0, it's repeated. If it's positive, we did a
It's two
few.
real number.
We get 2 real solutions.
Real solutions. Yeah.
Now they can ask you, how many real solutions are you getting? How many imaginary solutions are you getting? They could ask these like kind of different ways. So if, let's say that this is a situation, we're getting a negative underneath for our determinant. How many real solutions would we get if our determinant was negative?
Two imaginary.
We're getting 2
Mm,
imaginary. How many of those are real?
One?
It's 1 is a real number. Sorry.
If we're getting 2 imaginary,
One real one?
how many of those are real? We're getting 2 already. We're expecting 2, and both of those 2 are imaginary. How many of those imaginary things are going to be real?
No, no one.
None of them, right?
No
So
one. No.
this is 2 imaginary, but there are no reals,
No. Yeah. Because
right?
they are imaginary numbers.
Because both of those imaginaries are both of those solutions are taken account for with the imaginaries, right? And imaginaries aren't real. Those are different things. They're the
It's a
opposite.
tricky
Right?
question.
It's a tricky question sometimes because they'll ask you how many real solutions are there, and you'll get, oh, there's 2 imaginary. Well, there's no reals then. If it's 1 real, that just gives you 1 real. Okay, 2 real. So it can be 0 real, 1 real, 2 real, basically. All the different possibilities of how many different real solutions we could get. I think in the notes they even changed what these were. So let's do one right quick. We don't have much time, but I'll do one right quick. Let's do that first one. B squared minus 4ac. So if I'm doing that first one, I have 1r squared plus 12r plus 36. If I'm filling this in, it should look like 12 squared minus 4 times 1 times 36. I believe this is giving me 144 over here, and I have to subtract 4 times 36.
Yeah, it's 144 too.
That's also 144. So this is going to end up giving me 0 in my determinant. And so what does that mean about my solutions? How many real solutions am I going to get?
1 real solution repeated.
I'm going to get that one solution that's being repeated, right?
Yeah.
All right, and we are at the end of the class, so I think we have to cut it off there. We got 2 more to finish up there with the determinant. But really, I feel like the determinant is more of something that you're going to use to tell yourself, like, how many solutions does this thing have? Is what they really want you to think. Is the thing underneath the square root negative? Then it's going to be imaginary numbers that we're talking about. Is it 0? We're going to get that weird thing where we add and subtract 0. It's going to be the same thing. We're going to get that one solution. Is it positive? Then we're going to get 2 real solutions, kind of like we were expecting I feel like that's the typical sort of case. We're getting two numbers out of that, just like we were thinking. Okay, and that's it. Let me stop.